What's up, 20-1? Lesson 7 here, so page 19 in the note pack if you're following along. We're going to look at solving quadratic equations by factoring. Now, in order to be able to solve quadratic equations by factoring, what we need to know is just how to factor overall. Now, we've already kind of reviewed this flowchart for factoring, where the first thing I always want to do is start off and determine if there is a greatest common factor within that quadratic. And if there is, I would divide that out evenly from each term. The second thing I want to ask myself is, like, how many terms are there? If there are only 2 terms, I would go solve using difference of squares, which is, remember, essentially square rooting each term and creating conjugates. If there are 3 terms, right, if I have something in this form, ax squared plus bx plus c, and if a is 1, so if a is 1 or the leading coefficient is 1, I'm just simply looking for 2 numbers that multiply to c and add to b. And we should know how all of these other factoring strategies work, right? We kind of went through this on the board, and you kind of took a paper, you put it sideways. So if you have that factoring sheet and you want to grab it out, now would be the time to do that, because I'm going to go talk about factoring when a does not equal 1, because that leads into the lesson here that we're going to be looking at today. So the last part we need to talk about for factoring here is looking at factoring when a does not equal 1. So having a trinomial, for example, like, what am I going to use here? 8x squared minus 6x minus 5. So if I look at this trinomial right here, I cannot remove a greatest common factor. There's 3 terms. A does not equal 1, right? The leading coefficient is 8. And so I can't use any of the other factoring strategies that I've been looking or using up to this point. So I'll write some steps here. And really, you can factor every single other question up that might fall into these other categories using this strategy. And so I'm just going to write some steps. So the first step you're going to do is look for 2 numbers that multiply to a times c and add to b. So 2 numbers that multiply to a times c and add to b. So in this example, I'm looking for 2 numbers that multiply to 8 times negative 5. So 2 numbers that multiply to negative 40 and add to negative 6. So 2 numbers that multiply to negative 40 and add to negative 6. So those numbers, if you know them off the top of your head, that's good, right? Well, like 8 and 5 doesn't work because that will never add to 6. 2 and 20 isn't going to work because that won't add to 6. The 2 numbers I'm looking for are a negative 10 times 4. Negative 10 times a positive 4 is negative 40. Add those together, I'll get negative 6. So those are the numbers I'm looking for. When I find those numbers, I need to split the middle term into, so split the middle term into the 2 numbers from step 1. Step 1. And then when I do that, I need to make sure I include the variable, because I'm not going to change anything. I'm still making it equal. I'm just writing it different. So I'm going to split this middle term into a negative 10x and a positive 4x. Now, I haven't changed my equality because negative 10x plus 4x is still negative 6x. I just changed the way that it was written. Everything else is going to stay the same. That's 2 minus 5. Okay. Next thing I do, and hopefully you remember this, is I want to put brackets around the first 2 terms and the last 2 terms, and I'll factor out a GCF. So brackets around first 2 terms and last 2 terms. And then I'm factor factoring out a GCF. Sorry, my writing's probably pretty messy. I'm just writing on the screen with my finger. So brackets around the first two terms and the last two terms. So brackets around the first two terms, last two terms. So I just group them together. And then I'm going to remove a greatest common factor from each of those. So in the first set of brackets, what's the greatest common factor between 8x squared and negative 10x? Well, the greatest common factor there would be a 2x. And so I don't get rid of that 2x, right? I just write it to the front. So write it in the front, so 2x. And then what's left after each term has been divided by the greatest common factor. So 8 divided by 2 is 4, and x squared divided by x is just x. And then negative 10x divided by 2 is going to, 2x, pardon me, is going to give me a negative 5. So that's my first set of brackets. Second set of brackets here, 4x minus 5. Well, technically there is no greatest common factor there, or the greatest common factor in this case would just be 1. So out front, I write a 1, positive 1. And what's left in there is 4x minus 5. Now, it's not always going to be 1 here. It could be 2. It could be 25, whatever. In this case, it just happens to be a 1. And I have this really nice thing happening at this point if I have factored correctly, and if the question was, in fact, factorable, is that you can see what's left in brackets is exactly the same. And so then what I can do now is essentially divide that out as a greatest common factor. And so my fourth step is what is left in brackets should be identical. What's left in brackets should be identical. So this is one factor. This is one factor. And then what's left in front is the other. What left in front is the other factor. So what's left in front is the other factor. All right. So if I come back, and so I'm looking up here, right? So really what I'm doing is I'm dividing out 4x minus 5 as a greatest common factor. So 4x minus 5. That becomes one of my factors, 4x minus 5. The other factor comes from what's left in the front. So 2x plus 1, that becomes the other binomial that's left over. So 4x minus 5, 2x plus 1. Okay. Just leave this down here for a sec if you need it. Okay. So with that information and using this little flowchart to help me kind of navigate the factoring questions, we're going to go into lesson 7. So lesson 7 is solving for quadratic equations by factoring. And so the whole point of this factored form we've already kind of talked about is this is useful for finding the x-intercepts. And so my x-intercepts are kind of the opposite of what they appear in those factors. And so really what you're doing is you're making your factors equal to 0 and solving to find the x-intercepts. And we're going to go look at some questions of that. The other reason that factored form is useful for is obviously I can tell my a value, right? It tells me if it opens up and down, and it tells me my vertical stretch. The other thing that I can do is I can actually use my x-intercepts. So use x-intercepts to find my axes of symmetry. So let's go look at what I mean for that. I'm actually going to start on B rather than A because B is a bit easier. So B gives me the equation y equals x squared, x plus 4 times x minus 3. Now, if I really wanted to cheat, I could go type this in on my calculator and I could get the graph and I can copy it over here. However, I should be able to tell some information from this graph or from this factored form. I know from this, if I make x plus 4 equals 0, it's going to give me an x-intercept. So minus 4, minus 4. So there's an x-intercept at minus 4, right? The opposite of what it appears in there. So minus 4, there's an x-intercept. The other one would be from x minus 3. So x minus 3, I make that equal to 0. To solve for x, I add 3 to either side. So there's an x-intercept at positive 3. So an x-intercept at positive 3. The other thing I would need to do is I know that the coefficient here is 1, so it's going to open up. And I can also find my axes of symmetry from this piece of information, because my axes of symmetry is going to take your x-intercepts, add them together, and just divide it by 2. So just to rewrite that. Negative 4. Oops. I can also use my x-intercepts to find my axes of symmetry, because any 2 points on a quadratic, the middle should be right in between those if they're on the same horizontal line. So like if I'm looking at this, I'm thinking my axes of symmetry is probably somewhere in between, right in between negative 3 and negative 4. And so the way that I can find this is that my axes of symmetry is equal to x1 plus x2 divided by 2, right? I'm just finding the average or the middle between those 2 points. So in this case, I would be going negative 4 plus 3 and be dividing that by 2. So my axes of symmetry is actually at negative 1/2, which is exactly where we said. And so there'd probably be some minimum point somewhere down here. I don't really know just from this equation, but down here, the minimum at negative 1/2 and something, and then coming back up, maybe negative 12 or 12, 14-ish. Okay, so we can do the same thing with graph A here. So y equals negative 2x. So from here, I know this opens down. It's going to be a little bit narrower than my usual graph. I'd have an x-intercept at positive 1 and positive 7, right? Because I just make each of those equal to 0 and solve. The other thing I can do then, once I know those, is my axes of symmetry would be 1 plus 7 divided by 2. So 8 divided by 2, I have an axes of symmetry at x is equal to 4. So there'd be a line right on 4 that cuts this graph perfectly in half. And so if I'm going to sketch this, my graph probably looks something like that. Just from that equation, I can only tell, my x-intercepts, opening direction, and my axes of symmetry, but gives me a rough sketch. Okay, I can also graph that and verify those. Let's go look then at how we can solve quadratic equations by factoring. So if I'm going to solve quadratic equations by factoring, the first thing I need to do is I need to bring all the terms to one side. So I need to bring all the terms to one side. So I'm going to be like, my equation needs to equal 0. only then can I factor, right? That's essentially saying like once I have that equaling 0, I'm trying to go find the x-intercepts because the zeros like we did graphically. So let's go do some of these. So the first one, x squared minus 25 equals 0. Now really simple, I could find this by solving on my graphing calculator. Graph it, find my x-intercepts or my zeros. But I want to go solve with my factoring strategy. So if I look here, there's no greatest common factor. There's only 2 terms. And I should be able to factor this with difference of squares. 2 terms, both are perfect squares, and they're being subtracted. So if I'm going to solve this, right, I'm essentially square rooting each term. The square root of x squared is x. The square root of 25 is 5. And I break those into conjugates. So 1 positive, 1 negative. And we're trying to find where each of those equals to 0. So I factor that out. Now, to help me find my x-intercepts, I'm essentially breaking these factors up and making them individually equal to 0. Because that's how, make the y equal to 0. That's how I find my x-intercept. And so to solve for x, now if you can kind of see what the x-intercepts are, you don't have to do this work, but you may need to until you kind of understand. So I minus 5 from each step. So there's an x-intercept at negative 5. Do the same thing to my x minus 5. So the opposite of minus 5 is add 5. And then there would be an x-intercept at positive 5. Okay, if I'm not sure, there's a whole bunch of different ways I could go to check that. I can go graph it on my calculator and find my zeros or find my x-intercepts. I can substitute these points back up into my original equation, and they should equal 0 because like negative 5 squared is 25. 25 minus 25 is 0. So I know both of those should be okay. All right, let's go for B. So B is x squared plus 12x equals negative 35. So to solve these questions, the first thing I need to do is get everything to one side. So I'll add 35 and add 35. Be careful you don't incorrectly combine unlike terms here, right? X squared plus 12x plus 35. I can't add 35 to the x squared or to the 12x because they're not like terms. So if I now look at that question and I want to factor it, it's 3 terms. And, right, so I'm looking here, okay, it's 3 terms. And my leading coefficient is actually a is equal to 1, right? There is no leading coefficient here, or the leading coefficient is 1. So nice question. I'm just looking for 2 numbers that multiply to 35 and add to 12. You know those numbers off the top of your head, great. If not, you kind of got to figure it out. The 2 numbers that would do that are 5 times 7. 5 times 7 is 35, and 5 plus 7 is 12. When I have a equals 1, that's awesome. I don't have to do a whole bunch of work because I just put those in as my factors. So x plus 5, x plus 7 equals 0. And again, to solve for my x-intercepts, I'm just making each of these equal to 0 and solving them. I can look at this and already say, oh, it's negative 5, positive 5. But if you can't, do the work here where I subtract 5. So my x-intercept is at negative 5. And I do the same to get this 7 by itself. So subtract 7 from either side. So x is equal to negative 7. And C, so 3x squared plus 5x equals 0. Got to go through my steps. The very first thing I want to do, if possible, is remove a greatest common factor. And I can actually remove a greatest common factor here. And this equals 0, so I don't have to move anything. But x and x, or x squared and x, I can actually remove a greatest common factor here of x. So I'm left with x. And then when I divide 3x squared divided by x is 3x. And 5x divided by x is plus 5 equals 0. And I can't actually factor that anymore because it's no longer a quadratic or it doesn't have a higher degree. So now I have 2 factors that I both need to make equal to 0 to solve. Now, this one's not as easy to be like, oh, it's equal to this number. It's not just -5 because I have a coefficient here. So I'll make each of these equal to 0. Well, x is equal to 0. Well, that's good. It tells us what one of those are. And then I need to go 3x plus 5 equals 0. So to solve here, I'd subtract 5 from either side. 3x is equal to -5. And so to get x by itself, I divide by 3 on either side. So my other answer here is x is equal to -5/3. Okay, and I could check that algebraically or graphically. So what I've done for these is I factored them to the point where I know the x-intercepts for those graphs. Once I know my x-intercepts, I could find my axis of symmetry and my vertex from there if I wanted to. I'm gonna go do maybe 1 or 2 more here. So D is 3x squared minus 13x equals 10. The very first thing I need to do is get everything to one side. So I'm gonna subtract 10 here and subtract 10. So I have 3x squared minus 13x minus 10 is equal to 0. If I go back and look at my factoring flowchart here, there is no greatest common factor between those numbers. I have 3 terms. Let's go back. I have 3 terms here, and I'm looking to have a leading coefficient of 3, so I have to solve using this strategy. And so that strategy now means I need to include the leading coefficient in the 2 numbers that I'm multiplying to, and then I need to split the middle term. So for this question, I'm looking for 2 numbers that multiply to 3 times -10. So 2 numbers that multiply to -30 and add to b, which is -13. So 2 numbers that multiply to -30 and multiply to -13. Well, 3 times 10 multiplies to 30, but even if I do one negative, it'll only add to -7 or +7, which doesn't get me there. So the 2 numbers I'm actually looking for here are going to be -15 and 2. Once I figured out my factors, I split the middle term. So 3x squared minus 15x plus 2x. So I split the middle term. Again, I didn't change the equality. It's still equal. It's just written different. And then minus 10 equals 0. Once I split the middle term, brackets around my first 2 terms, last 2 terms, and then I divided GCF out of each set of brackets. So in my first set of brackets, the greatest common factor would be 3x. So that goes to the front. And then I will write what's left after I've divided the GCF out of the factors in the brackets. So 3x squared divided by 3x squared is just going to give me x. And -15 divided by 3 is -5. Next set of brackets, I'm looking to remove the greatest common factor, which is 2x minus 10. So the greatest common factor is 2. That comes to the front. That's a +2. And then each term gets divided by 2. So 2x divided by 2 is x. And -10 divided by 2 is -5. And so if I want to write that all together, or I guess as my final set of factors, I know I'm on the right track because what's left in brackets is the same. That becomes one set of factors. And the other set of factors is from what's left in front. So 3x plus 2. Now I factored it, that's great. But what's the whole point of factoring here? Well, the whole point of factoring is to be able to find out what my x-intercepts are. So I need to go make each of those equal to 0 to go find out what the values of them are. So x minus 5 equals 0. So I'd add 5, add 5. So I have an x-intercept at 5. And I would have one from this, 3x plus 2. Where does that equal 0? So I'd subtract 2. So 3x is equal to -2 and divide by 3. So x is equal to -2/3. Okay. If I want to check, I'm like, did I do that right? Well, let's go see if I did do it right. I'm going to go graph my original equation. Usually I go graph like exactly what the question gave me, just in case maybe I made a mistake even just rearranging there. So I'm going to go graph that, where y1 is 3x squared minus 13x, and this other one is just 10. So I'll graph that. I'm probably actually going to have to zoom out because the line's going to be at the very top. Oh, I might be able to find it. And I'm just looking for the intersects here. And my x values in my intersects should be the same as my factors. So negative, first intersection is at negative 0.6 repeating, which is equivalent to 2/3. So I know this one's okay. And I'm going to go check the second one. So second, calculate the intersection. First curve, enter. Second curve, enter. Guess. I want to get close to that second x-intercept over here. If it lets me go there. There we go. Hopefully that's close enough. Yeah, and another one at 5. So I know that I did that right. Okay. Hopefully that's, you kind of remember how to factor there. It's really nothing too different this lesson from what we did in 10C in terms of factoring. Now we just need to go a little bit further to go find and solve for your x-intercepts. So what I want you to do here for the rest of the day today is practice your factoring and practice finding the x-intercepts of quadratic functions. So you're going to look at homework 7, number 1. This is going to be really weird because I kind of numbered this weird. It's going to be A, B, E. So A, B, E, F, G, H, I. Those are just basic factoring questions, not even trying to find out the x-intercepts. The next one is going to be number 2. I want you to do that one where it's actually already in factored form. You just need to state the x-intercepts. And then number 3, which is, again, probably going to be some weird questions here. Number 3, A, B, C, D, H, I. Skipping some that have like fractions, and you have to solve with different, more difficult strategies that we'll look at when we come back on Tuesday, long weekend. Okay, so try those. If you're struggling, I'll be back on Tuesday. We'll kind of crush factoring and then go look at some more problems. So have a good weekend.